Kepler Station 9 hung in the cosmic void like a testament to industrial ambition and questionable architectural decisions. The massive orbital platform had been constructed around a dying star's gravitational well, primarily because someone in the Intergalactic Trade Consortium had decided that free energy and convenient metal refining conditions were worth the minor inconvenience of living next to a stellar furnace that occasionally burped radiation storms. The station served as the consortium's premier heavy manufacturing facility, where apprentices from across the galaxy came to learn the noble art of turning raw materials into useful objects through the application of overwhelming force. It was, according to the promotional materials, where genetic destiny meets industrial necessity, which was corporate speak for if your species can't crush metal with their bare appendages, perhaps consider a career in food service. The apprenticeship program had been running for 3 centuries, long enough to establish certain unshakable truths about manufacturing excellence. The arachno-industrials, with their 8 specialized limbs and exoskeletons that could withstand molten metal, naturally dominated precision fabrication. The Stoneskins brought geological-level compression forces to bear on stubborn materials. The plasma-born could heat-treat steel using nothing more than their bioelectric fields and a moderate amount of concentration. These were the facts of industrial life, as immutable as physics and considerably more profitable. The strong-shaped metal, the weak filed paperwork, and the universe maintained its proper order through the simple expedient of putting beings in roles that matched their evolutionary advantages. Master fabricator Quin'thex had built his considerable reputation on understanding this natural hierarchy. His workshop in Section 7 Delta was considered the station's most prestigious training ground, partly because he consistently produced the finest craftsmen, and partly because apprentices who disappointed him had a tendency to find themselves reassigned to waste reclamation duties in the station's less pleasant sections. His 8 limbs moved with the fluid precision of someone who had spent 4 decades turning raw metal into objects of beauty and function. Each appendage ended in specialized manipulators, some for gripping, others for heating, cutting, or applying pressure with surgical accuracy. He was, by any reasonable measure, a perfect example of evolutionary fitness meeting industrial necessity. The workshop itself hummed with the kind of barely contained energy that suggested serious manufacturing was about to occur. Massive ferrosteel ingots, each weighing several tons, sat arranged on specialized workstations. These weren't decorative samples. Ferrosteel was the backbone of interstellar construction, used in everything from starship hulls to orbital platform superstructures. Working with it required either specialized equipment or the kind of natural abilities that most species could only dream about. Around the workshop, the current crop of apprentices prepared for the day's assessment. Velvar, whose stoneskin heritage meant his outer dermal layer could withstand direct contact with molten metals, was reviewing stress calculations with the casual confidence of someone whose ancestors had literally eaten mountains for breakfast. His species had evolved on a world where the primary food source was mineral deposits, and their digestive systems had developed the delightful side effect of making their skin harder than most conventional armor. Nearby, ZY-Xandra's bioelectric fields created small lightning storms around her workstation as she calibrated her internal energy distribution systems. The plasma-born had evolved in the coronas of gas giants, where generating and controlling electrical fields was the difference between feeding and becoming someone else's dinner. In industrial applications, this translated to the ability to heat-treat metals with the kind of precision that made conventional furnaces seem like crude approximations. Quin'thex, whose pressure-adapted physiology allowed him to function normally under atmospheric conditions that would crush most species into interesting geometric shapes, was testing his grip strength on sample materials. His people had evolved in the crushing depths of oceanic trenches on high-gravity worlds, where atmospheric pressure was measured in terms that made conventional physics weep. For industrial purposes, this meant he could apply compression forces that typically required massive hydraulic systems. Then there was Elena, who sat quietly at her workstation reviewing technical specifications on a datapad that looked suspiciously like it had been manufactured by the lowest bidder. She represented Earth's latest attempt to prove that humans belonged in heavy industrial applications, despite the obvious evidence that their evolutionary history had prepared them for little more than persistence hunting and making increasingly complex tools to compensate for their physical limitations. Quin'thex had reviewed her file, naturally. Standard human physiology, carbon-based skeleton that would shatter under the pressures routinely applied in heavy manufacturing, muscle density that wouldn't impress a juvenile from most industrialized species, and a cardiovascular system that required constant maintenance just to function in normal atmospheric conditions. Her theoretical scores were respectable. Humans always performed well on tests, probably because they treated everything like an elaborate puzzle. But theory and industrial reality was separated by the fundamental gap between knowing and doing. Today's assessment, Quin'thex announced, his primary voice resonating with the authority of someone who had personally fabricated components for 3 different space elevator projects, involves precision forming of structural-grade ferrosteel. He gestured toward the collection of ingots with movements that suggested casual familiarity with materials that could stop projectiles designed to pace starship armor. You'll be required to produce components matching these specifications within acceptable tolerances. He activated a holographic display showing technical drawings that would make most engineers pause to appreciate their complexity. These weren't simple shapes. They were precision industrial components with tolerances measured in micrometers, featuring stress relief channels, load distribution geometries, and integration points for advanced composite materials. The kind of parts that held space stations together when the universe decided to test their structural integrity. In real manufacturing environments, Quin'thex continued, you won't have the luxury of perfect conditions or unlimited time. Industrial excellence requires the ability to produce precision components efficiently, reliably, and without requiring exotic equipment for every operation. The implications hung in the recycled atmosphere like an unspoken challenge. This was advanced structural fabrication, where theoretical knowledge met the brutal reality of industrial necessity. Sometimes you needed to shape the building blocks of civilization quickly, precisely, and without the benefit of massive automated systems. Velvar approached his ingot with the confidence of someone whose species considered ferrosteel a moderately challenging warm-up exercise. His stone-hard skin made direct contact with the metal, and he began applying pressure with the kind of gradual, relentless force that geological processes used to reshape continents. The ferrosteel groaned in protest, but slowly, inevitably, began to deform according to his will. The sound was impressive, a deep, resonant complaint from metal that was accustomed to being treated with considerably more respect. Velvar's technique relied on pure compressive force, gradually crushing the ingot into the approximate shape specified by the technical drawings. His natural dermal armor allowed him to maintain direct contact with the metal throughout the process, feeling stress patterns and structural responses that most beings could only detect through sophisticated instruments. Acceptable work, Quin'thex nodded, though his tone suggested Velvar was meeting minimum standards rather than achieving excellence. HFY. The plasma-born approached her workstation with movements that created small electrical discharges in the surrounding air. Where Velvar had relied on brute compressive force, HFY demonstrated the elegant application of controlled energy. Her bioelectric fields began heating specific areas of the ferrosteel ingot, creating zones of malleability that allowed for more precise shaping. The metal began to glow with heat-induced luminescence as HFY systematically worked through the component geometry. Her technique created controlled thermal gradients that softened strategic areas while maintaining structural integrity in load-bearing sections. The result was a component that matched the technical specifications while displaying the kind of smooth surface finish that suggested professional-grade manufacturing. Better, Quin'thex acknowledged. More Unix. The pressure-adapted apprentices approach combined elements of both previous demonstrations while adding his own species' particular advantages. His grip could apply forces typically associated with industrial presses, but with the precision control that came from evolved sensory systems designed to function in extreme pressure environments. He systematically worked through the component geometry, creating precise stress patterns that shaped the ferrosteel into increasingly complex configurations. Within minutes, he had produced a component that not only matched the specifications but featured internal stress distributions that would actually improve its structural performance under load. His evolutionary heritage had given him an intuitive understanding of how materials behaved under extreme pressure, allowing him to optimize the component's internal structure during the forming process. Several other apprentices demonstrated their species' particular approaches to precision manufacturing. A crystalline being used harmonic resonance to induce controlled material flow, while a graviton manipulator created localized space-time distortions that allowed for stress-free forming operations. Each display showcased the casual superiority that had earned these species their places in the consortium's industrial hierarchy. Eventually, predictably, attention focused on the human sitting at the corner workstation. Quin'thex's voice carried the particular tone that supervisors used when they were about to make an educational point at someone's expense. "Our human representative, please demonstrate your species' approach to precision ferrosteel fabrication." Elena looked up from her datapad with the expression of someone who had been genuinely absorbed in technical documentation rather than procrastinating. Her brown hair was pulled back in a practical style that prioritized function over appearance, and her work clothes were standard issue rather than the specialized protective gear some species required for high-temperature operations. Everything about her suggested baseline industrial worker with no obvious adaptations for strength, heat resistance, or pressure tolerance. She stood, all 1.65 meters of her, and approached the remaining ferrosteel ingot with what could optimistically be called confidence, though skeptics might characterize it as delusion. Her hands were exactly what evolutionary biology would predict for a species that had developed tool-making as their primary survival strategy: opposable thumbs, sensitive fingertips, and absolutely no visible muscle mass worth mentioning in an industrial context. "Standard ferrosteel ingot," she said, running her fingers along the metal surface in what appeared to be casual inspection. "Iron-carbon matrix with embedded nanoscale reinforcement fibers. Designed for high-stress structural applications, with excellent fatigue resistance and predictable failure characteristics." Quin'thex's mandibles clicked in what might have been amusement. "Indeed. And your fabrication strategy?" "Well," Elena said, settling onto the adjustable stool at her workstation, "overwhelming force is certainly one approach." Her tone suggested this was roughly equivalent to using a fusion torch to light a candle. Technically effective, but fundamentally missing the point. The workshop fell silent except for the ambient hum of life support systems and the barely audible sound of several dozen beings trying not to laugh out loud. The human was going to attempt precision ferrosteel fabrication while sitting down. The absurdity was almost artistic in its completeness. Ferrosteel's industrial properties derive from its controlled crystalline structure and nanoscale reinforcement distribution, Elena continued, apparently oblivious to the suppressed amusement around her. But engineered structures have engineered weaknesses. The reinforcement fibers follow predictable patterns based on manufacturing efficiency and cost optimization. She activated a small heating element, standard workshop equipment that most apprentices used for preliminary material preparation, and began applying controlled thermal cycles to specific areas of the ingot. To most observers, it looked like she was gently warming the metal rather than attempting serious fabrication work. "Heat treating," she said conversationally, "is materials engineering through controlled thermal manipulation. When you understand the relationship between temperature, time, and structural transformation." She adjusted the heating element's position, following what appeared to be a systematic pattern across the ingot surface. "You can convince materials to reconfigure themselves rather than forcing them into new shapes." The ferrosteel, which had required tons of applied force to deform even slightly for the other apprentices, began developing subtle changes in its surface characteristics exactly where Elena's heating element had been applied. The silence in the workshop took on a different quality. Where before it had been the silence of beings trying not to laugh, now it was the silence of beings trying to process something that challenged their understanding of industrial manufacturing. "The key principle," Elena continued, beginning to apply gentle pressure to the heat-affected areas, "is understanding that you're not fighting the material structure, you're optimizing it." The ingot began developing controlled deformation zones that followed the precise geometry specified in the technical drawings. Quin'thex's 8 limbs hung motionless at his sides. In his extensive industrial career, he'd seen stone-skin fabricators crush components into shape through pure compressive force. He'd watched plasma-borne specialists heat form metal using bioelectric fields that could power small cities. But he'd never seen anyone sit on a workshop stool and convince ferrosteel to reshape itself through what appeared to be gentle suggestion combined with basic thermal cycling. "Humans," Elena said, creating a precisely controlled stress relief channel through the systematic application of localized heating followed by controlled cooling, evolved as tool-making problem solvers. We didn't develop massive strength or exotic energy manipulation because we learned early that understanding materials could substitute for overpowering them. The component was taking shape with tolerances that matched the technical specifications, while requiring a fraction of the energy expenditure demonstrated by other apprentices. She paused to check her measurements using precision instruments, then resumed the systematic thermal cycling process. Industrial manufacturing isn't about overwhelming your materials, it's about understanding them well enough to make them want to cooperate with your objectives. The workshop erupted in the kind of controlled chaos that typically followed paradigm shifts. Veldar was examining his own component, trying to understand how crude compressive force had required so much more effort than the human's seemingly effortless technique. Alexandra's bioelectric fields were fluctuating with what appeared to be confusion as she compared her energy-intensive approach to Elena's minimal power requirements. "Explain the principles," Quin'thex said, and his tone carried none of its earlier condescension. This was the voice of a professional fabricator, encountering something that challenged fundamental assumptions about manufacturing excellence. "Controlled material transformation," Elena replied, calling up holographic displays that showed thermal gradients and stress distribution patterns. Every engineered material has optimal conditions for structural modification. Humans spent millennia learning to identify and exploit these conditions because we couldn't simply overpower our manufacturing challenges. The holographic data painted a picture of elegant efficiency. Where other species had applied massive forces or exotic energies broadly across the material structure, Elena had identified specific thermal and stress patterns that would cascade into precisely controlled structural transformation. "Your approaches achieved equivalent results," she continued, nodding toward the various components around the workshop, "but required approximately 15 to 20 times more energy expenditure to create components that were functionally identical to what I produced using basic thermal cycling and controlled stress application." Ingenuity, who had been studying the human's component with the intensity of someone questioning everything he'd ever been taught about manufacturing, raised a massive hand. "But industrial strength is one approach to manufacturing challenges," Elena finished. "Just not the only approach, and often not the optimal approach. Humans developed manufacturing techniques that multiplied our capabilities through understanding rather than relying on evolutionary advantages." She gestured toward her precisely formed component. "In real industrial environments, this approach offers several significant advantages. Lower energy requirements mean reduced operating costs. Precise thermal control means better metallurgical properties in the finished components. And the techniques can be taught and replicated regardless of individual biological capabilities." Quin'thex found himself experiencing something uncomfortably close to professional respect. Throughout his career, he'd measured manufacturing excellence in terms of force application, how much pressure could be generated, how quickly, and with what degree of overwhelming superiority. The human approach suggested that excellence might be better measured in terms of efficiency, precision, and adaptability. Furthermore, Elena added, apparently warming to the technical discussion, this approach scales effectively. The same principles that allow precise component fabrication can be applied to larger manufacturing challenges. Starship hull construction, orbital platform assembly, even emergency repairs in hostile environments where you need to modify structural components without compromising system integrity. The implications began settling over the workshop like a slow-moving avalanche of realization. Human industrial doctrine, which most consortium engineers dismissed as overly theoretical, suddenly appeared in a different light. Where other species relied on superior strength and exotic capabilities, humans had developed approaches based on material science, process optimization, and systematic understanding. "Of course," Elena said with a slight smile that suggested she was aware of the mental recalibrations happening around her, "raw force certainly has its applications in heavy manufacturing. But in precision fabrication, understanding your materials is often more valuable than simply overpowering them." She began cleaning her workstation with movements that seemed casual but were probably optimized for maximum efficiency. The galaxy's full of beings who can reshape ferrosteel through brute force or exotic energy manipulation. But how many can convince it to reshape itself exactly according to specifications, using nothing more than basic thermal cycling and an understanding of material science? The question hung in the recycled atmosphere, like a challenge wrapped in an observation. Around the workshop, representatives of the galaxy's most industrially impressive species found themselves reconsidering fundamental assumptions about manufacturing excellence, efficiency, and the relationship between capability and understanding. Quin'thex watched the human return to a technical documentation, as if nothing remarkable had occurred. In the space of 30 minutes, she demonstrated that his species' approach to precision manufacturing, indeed, most species' approaches, were roughly equivalent to using a plasma cannon when a precision laser would achieve better results with vastly lower energy requirements. The truly unsettling part wasn't that humans had developed alternative approaches to industrial challenges. It was the growing realization that their alternatives might actually be superior in most practical applications. Raw force was impressive, but efficiency was profitable. Exotic capabilities were fascinating, but understanding was reliable. As the assessment period continued and other apprentices attempted to replicate Elena's thermal cycling methods with varying degrees of success, Quin'thex found himself wondering what other limitations of human physiology might actually be sophisticated adaptations to different problem-solving approaches. Their supposedly weak skeletal structure that required constant maintenance also provided remarkable adaptability to different gravitational environments. Their lack of specialized industrial appendages was compensated by tool-making abilities that allowed them to adapt to virtually any manufacturing challenge. Perhaps most disturbing of all was the realization that human industrial philosophy, with its emphasis on process optimization, quality control, and systematic improvement, wasn't compensation for biological weakness. It was optimization for manufacturing excellence. They'd taken the same approach to fabrication that Elena had taken to ferro-steel forming, understanding the problem so thoroughly that solutions became elegant rather than overwhelming. The assessment period ended with a kind of thoughtful silence that typically followed genuinely educational experiences. As apprentices filed out, many paused to examine Elena's component, comparing its precise tolerances and optimized internal stress patterns to their own more dramatically fabricated pieces. Veldar approached the human as she prepared to leave. "Your thermal cycling technique," he said carefully, "could it be adapted for use by other species?" "The principles certainly could," Elena replied, "though you might need to recalibrate your approach to force application. Your natural strength could actually be integrated with thermal control methods to achieve even better results than either approach alone." The Stoneskin's expression suggested this was possibly the first time in his evolutionary history that someone had characterized his superior strength as something that could be improved rather than simply applied. Quin'thex remained at his workstation long after the workshop had emptied, examining the precision components his apprentices had produced with new understanding. Tomorrow's curriculum would require significant modifications. Today had been designed to demonstrate the superiority of evolutionary advantages over theoretical knowledge. Instead, it had become a masterclass in why theoretical knowledge, properly applied, could make evolutionary advantages seem crude and wasteful. The human had smiled, not obviously, but Quin'thex was experienced enough to recognize the subtle signs of someone who had achieved exactly the educational impact they'd intended. She'd known precisely what would happen when she began that systematic thermal cycling process. The entire demonstration had been calculated to achieve maximum instructional value with minimum energy expenditure. Just like everything else about human industrial philosophy, apparently. He made a mental note to review the station's manufacturing curriculum standards. If humans could achieve superior results through process understanding and material science rather than raw capability, then perhaps the consortium's emphasis on biological advantages was missing crucial elements of manufacturing excellence. The irony wasn't lost on him. He'd spent the assessment demonstrating why evolutionary fitness made certain species natural industrial leaders, only to discover that true leadership might lie in approaches his people had never considered necessary to develop. Outside the workshop's observation ports, the dying star continued its stellar death throes while Kepler Station 9 maintained its orbital position with mechanical precision. But inside Workshop 7 Delta, The fundamental assumptions about capability, efficiency, and manufacturing excellence had been quietly revolutionized by a human who'd shaped ferrosteel without even bothering to stand up. The instructor had indeed laughed at her fragile hands. The universe, it seemed, was having the last laugh.